Hi, I'm Stephan Eggermond
I'm Willem van den Ende.
with gtoolkit. We make microprints. Microprints help us with the things we are doing with LLMs. And
Large language models generate lots of code confidently. And for production software like our refactoring cardboard, we want to keep an eye on how much code it's generating, whether our refactorings are working, and yeah, keep track on this. We had some prototypes where a graphical board expanded into 30,000 lines of TypeScript, and neither we nor the large language model could make sense of the code and make meaningful changes. So our decisions, we use these boards to decide to bin our change, or bin the entire repository, refactor it, or continue.
and I knew that microprints existed. That was part of Moose. So I looked up how that actually worked.
Moose was a research project funded by the EU that created legacy code analyzers.
So what do you see here? You see here for a file. This is some code.
This is a test of the heads-up display, which is the thing at the bottom that tells you a bit about what's going on in the display.
We have a very small display for this. So for each line of code, we make a line of pixels, and we color it based on what kind of thing we are seeing.
Things we are interested in. So you can see on the right, there is right 800, that's a number, bottom 600, width 600. So the numbers are green. So anywhere on the left where you see green, like this thing, point test, there's a lot of green here. And then we can click on it, and then we see lots of numbers, screen point 100, 200. Oh, the same screen point, 100, 200. So this tells us, gives us an idea, oh, there's lots of numbers. That's an opportunity to refactor our tests so they speak more clearly. So probably all these tests could be turned into one-liners. We have done this with some other tests in this code base, but not with this test. We tend to, like with legacy code, we tend to focus on the goal we have at the moment. So we had some problems with panning. We wanted to fix panning. So in that area, we have refactored, but not in this area.
Yeah, and the first thing we see at a glance here is that we have some large files and some small files.
And some tiny files even.
Yeah, and basically when developing software, we want to distribute our code over a reasonable number of files that should be, ideally around the same size.
Because for large files, it's difficult to make an assessment of it and have an opinion about it. We know from research on peer reviews, pull requests, that people say, it's 1,000 lines, yeah, there's this change here. Yeah, it looks good to me. But when it's a small file, you get lots of feedback.
Yeah, we can see that here. This seems to be a very large one. So there's lots of things going on there. And it should zoom in on negative delta I with control key. So it looks quite okay. But is this really okay?
So
that's quite difficult.
Events, they all sort of look the same, but this is a lot easier to refactor if we know that these are the same kinds of events that we are looking at. We might do because there's a before each there, so that probably there's a describe block on top of it, but you have to scroll for it. You have to dig. Yeah, there it is, just slightly lower. Describe card dragging. So this is probably a separate concern. So the refactoring that we tend to do, and we have done here for some other files, is tell our large language model and coding agent, oh, this test has a bunch of different responsibilities. Tell us the responsibilities. Okay, please split these responsibilities out into separate files. And then we look at the files that interest us and maybe split them up further, or extract out builder so our mouse events are focused on only the changes that we need.
Yeah. This is one of the basically quick and dirty kind of graphs that we make. We make them just good enough that they help us with our problem. We can also take a look at the whole repository that contains more than things, or sometimes we are only interested in input handling.
Yeah, like when we are trying to resolve an issue with penning on a Mac using Chrome, we need to we work in these 5 classes, or it's a bit more now. So normally that's a bunch of open tabs that we have, and now we can say, okay, we just want everything with input. We get the microprints, and we can easily go from one file to another. So we have a view of the forest on the left and the tree on the right hand side. So this gives us the whole and parts view that we like. So the input coordinator test is still quite big, but we have factored out input event parser and the input coordinator. And these are all reasonable size. So on input coordinator we can have an opinion now. So we can see, oh, the constructor is a bit big. You can see in the microprint on the left that there is quite a lot of indentation. So the level of nesting is quite high, which probably means that there's either complicated logic or other things that we can extract into clear responsibilities.
Yep. Well, we also use this for different things. We took a look at what we actually have for kinds of parsers in gtoolkit.
So the things that we use to build our tools with. So the microprints, they work on any language because they just work on strings. But sometimes we're might be interested in Markdown links or JavaScript consoles. And for that, there are parsers.
Yeah, this is one kind of parser, and this is another one. And the SMAC parsers, they are a bit larger.
So SMAC parses what?
SMAC is something which real...
So this parses C#.
Yeah. So that's pretty complex. That's over 2,000 lines. A C# parser in SMAC is something that is generated from this definition. So this the source code for this has a lot of methods that are just generated code. So for this code, it does not make much sense to visualize all the methods like we did for the other ones. For this one, we basically only need to visualize the grammar.
Right. So this thing on the left is only the grammar, or is that everything?
On the left is the grammar only, yes.
Yeah. Ah, okay. Yeah. So that's big.
Yeah, and if you have such a large grammar, then the amount of generated code is even far larger.
Yeah.
So this was what we wanted to show you about microprints.
Thank you for watching. If you have any questions, feel free to contact us.